Welcome to ToloTalks. I'm Dave Schmidt, one of the regional sales managers here at Tolomatic, and today I'll be talking about our Rodless actuators. I appreciate you guys attending today's presentation. So who is Tolomatic? Well, among being a leader in industrial automation and linear motion, we're a global leader in rodless cylinders and actuators with both pneumatic and electric rodless actuators. And Tolomatic created the first rodless cylinder for all of industry, which was the pneumatic cable cylinder back in 1955. We've also got proof that we're a global leader and that we've won back-to-back awards through control design. And this was a retained survey where over 13,000 people responded and recognized Tolomatic as linear motion actuator slides or guides as actual, through their research. And this was retained from memory. It wasn't just calling out and checking a box of Tolomatic or our competition. So we beat out some big names, as you can see in the list there, with Festo, Rockwell, SMC, and Parker. Tolomatic has one of the largest selection and array of rodless actuators in the industry. Again, both with pneumatic and electric. And today I'm going to focus on the electric actuators that we've got shown on the screen here. So what do you want to look for when selecting a rodless actuator? Well, the first thing is, what the load is, how much load you're going to be carrying with the actuator. And that's the FZ direction, the load that's directly applied to the carrier. Also, whether or not you've got that load offset, causing any bending moments. This is a moment compass here, and so, if you're off to the left or right, you're going to be in the FY or MY, the roll moment, and then the MX. Actually, the MX is the roll moment. The MY is the pitch moment along the FY axis if that load was offset, and then the MZ moment or your yaw moment. So we can add multiple carriers, providing twice the load carrying capability. We can do gantry configurations. Speed is also key, whether or not you're going to end up needing a screw-driven actuator or a belt-driven actuator. And then the accels and decels for the motor, getting up to speed and moving it accordingly and causing any inertia moments there. So then the stroke length, that also comes into play on whether or not you can use a screw or belt-driven actuator. We've also got environmental considerations to take a look at, and so those are things that we need to do. So I'm going to start with our oldest electric rodless actuator, which is the BCS, highlighted in the picture here. And screen keeps freezing up. Okay. So with the BCS, it's a screw-driven actuator. As you can see, we've got this one showing a Acme screw in here with a Delrin nut. Also shown down here, we can put a ball screw in there. Ball screw is going to be much more efficient and provide higher thrust capacities and so forth. This product has an adjustable carrier bracket, very similar to our BC2 product, that you adjust so that the Delrin bearing rods underneath here in the carrier are aligned properly and running smoothly in this groove of the extrusion. We've got external bumpers on here to prevent end of stroke runout and causing any damage to the screw or nut coupler. And this also has the traditional stainless steel sealing band with a polyurethane sealing design. Functions very similar to like a Ziploc bag and snaps both the seal band and in the pneumatic case, a dust band, or excuse me, a dust band on the top here. And then in the pneumatic would have a sealing band underneath there. But with the electric and the nut coupler, you don't need that sealing band because you don't have the unit under pressure there. So we're showing some of the options that we've got to auxiliary carriers, again, providing 2 times the load. We've got floating mount brackets for float in alignment when you're putting your end of or tooling on the carrier there, if it needs to not necessarily be constrained. We've got a lot of mounting options, surface mounts with mounting holes underneath, tube supports. There's a metric option available, and then of course we also have switches available which can snap into this groove underneath here and provide you home and end of travel limit switches. So the BCS product has up to 2,700 pounds of force capability. Again, force would be lateral and pushing against the extrusion, and then loads directly applied to the carrier of up to 300 pounds. This actuator can travel up to 50 inches a second and provide lighter MX and MY, again, the pitch and roll moment capacities, roll being over the top of the carrier. We've got 3 sizes available: a 1 inch, 1.5 inch, and 2 inch bore size. And so this actuator is ideal for light to mid-range duty cycle applications, guided load applications, and it does hold up very well in dusty and dirty environments. The 20 years later or 25 years later, we looked at doing a new and improved version, which we'll be talking about in 3 different versions here in my presentation today. The first of which would be the sister product to the BCS, and that's the MXE screw-driven actuator. So you can see it's very similar in design. So we've got the lead screw in here with a nut coupler, same screw technologies, the Acme screw and the ball nut option in there. Magnets come standard with this product, so where with the BCS you would have to call those out as an additional option. The magnets come standard on this, and so you can add switches which ride in this centermost groove here for end of travel and home locations. This band is a little different, the dust band, in that it's magnetically retained. There are 2 magnets embedded into the extrusion here, as you can see in the bright blue. And so as the carrier travels back and forth, the band ramps press that down onto those magnets and prevent any particulate from getting in there. We've also got what we call our Your Motor Here program. Most of you are probably familiar with that, and that Tolomatic is an industry leader in versatility there to accommodate any motor that you choose. We've got an archive of over 2,000 motors on file to machine up the motor mount coupler and match it to whatever motor you might use. One of the other features that the MXE offers, it utilizes the same Delrin material in the bearings, but it rides in a precision groove specially sized for the carrier itself. So you can see there's a little air pocket here behind the trapezoidal bearing. This can provide up to 60% longer life than the BCS, and it is easily field replaceable, where you don't have the BCS, you'd have to remove the carrier to change out the bearing rods. This one, you just have these little cap screws on each end, and this little piece comes off and the other end comes off, and then you can just slide that bearing out and replace it in the field. So it's very easy to change that out. Both the BCS and the MXES, again, have adjustable carriers. This one here is kind of a bi-wing design, and as is the BCS, but excuse me, we have the same 4 mounting holes as the BCS has in the center. Those are in the same location, but then if you've got a wider tooling plate or necessarily mounting holes, we've got 6 additional holes on the outside there. So it's got a large flexible mounting pattern on this product. This unit is also very cost effective. It has the same solid bearings that I was talking about, which are resistant to environmental contaminants. I personally have seen these used in paint booths and food applications where you've got flour or sugar transcending along the actuator itself, and it holds up very well there. So we've also got an auxiliary carrier available for, again, twice the moment load. Actually, it's just twice the load carrying capabilities, and it's compatible with your motor here, which I talked about, and ideal in clean and dry environments. This graph here shows some of the load carrying capabilities. Again, in the FZ, you can get up to 520 pounds of load on this actuator, so almost twice where the maximum load carrying capability of the BCS was 300 pounds. This one has almost twice that load capability. And we have the 6 sizes there. So if you were to compare the 2-inch, which would be the MXE 50, it's pretty comparable to the BCS at 315 pounds of load. But the bending moments get quite high. So again, traversing in parallel to the extrusion here, that MY moment can get up to 2,300, over 2,300 inch-pounds of bending moment capacity. So very robust product. And then again, the auxiliary carrier providing twice the load. A lot of times people want to know what the distance is here. The minimum on this and most of our products is about 8 inches on center here because of the piston brackets that are in there. So work with your applications engineer to get that fully defined for you on what that spacing needs to be. So again, here, if we look at the auxiliary carrier versus the single carrier, you're going to get up to, you get the twice the load carrying capability, and you actually get like 3 times the moment capacity there in some cases. So the MXES, again, has forces, thrust forces of up to 4,300 pounds, loads of up to 520 pounds, speeds of up to 50 inches a second. It has light to medium duty bending moments in the MX and the MY, and we do have the 6 extrusion sizes available in this. One of the application wins or unique application wins that we've had with this product is in the equestrian industry. And as you may wonder, well, how do you take an x-ray of a horse or a CT scan of a horse? Well, you're not going to get the horse to necessarily lay down on command or and such. So we built worked with a customer to build a CT scanner that lifted 3,000 pounds vertical head and needed to be very durable for the environment, required outside manufacturing and engineering support, and actuators and motion control systems. So we provided the MXE-S with the high thrust capability. We had the MXE-40s in a vertical installation here, and the MXE-63s down below here, moving these back and forth. So the horse would walk up onto the ramp here and be harnessed on the railing, and then move the CT scan up and down and back and forth laterally to conduct the scan there. We used a Kollmorgen motor here with a Keat coupler and safety spring ball screw assembly. What you may be wondering about that is if this scan got kicked or knocked, you didn't want that to be destroyed from the horse, so it enabled it to kind of operate back and forth, where if you lost power, that it wouldn't collapse back onto the and fall down on the actuator. So another product, same bearing technology, the solid bearing technology. This is one of the more recent releases. We just came up with this about, I don't know, 5 years ago or so, and utilizing the same solid bearing technology, but with a belt-driven design here. So instead of having the motor in line or in a reverse parallel motor mount orientation, we're off of one side, left or right-hand side. You can call that out as you need to. And so this also has the adjustable carrier with the locking screw. The smaller set screws lock this bearing into position, and then the larger set screws hold it from pivoting into the trapezoidal groove there. Again, here we've got 6 sizes available. Your forces with the belt drop down significantly by like 90%. As if you recall, we were up over 4,300 pounds of force with the screw-driven unit. The belt has a thrust capacity of only 418 pounds. However, the load remains the same, in that you can carry 520 pounds, but you do get twice the speed with the belt-driven unit, and that instead of 50 inches a second, you're getting 100 inches a second. And this too has your light to medium duty moment load capacities in all 6 extrusion sizes. This is also, a cost-effective solution, providing the solid bearing carriers, which are resistant to the environmental contaminants. This is all stuff we've talked about with the previous products. So, an application win for a belt-driven actuator here, that MXB-S, was in the paper and pulp processing industry. Actuators were needed to withstand the application and the environment on a brush roll machine. So as you're bringing in the media, you got a lot of dancers and so forth, and web tensioning to spool it and split it and splice it. So it's drawing the material in, feeding it, cutting it, turning it into corrugated cardboard boxes and everything. So For this application, we used the MXB40 solid bearing with open end caps, which you can see in this photo here. Reason that we had those open was because if you've got that pulp building up here, you could easily clean it and have it discharge directly through the ends of the and heads of the carrier as this was traversing back and forth. And this is an ideal product for thin film processing and web handling, flying knife cutoffs and so forth. Paper and pulp is certainly a market that we've done quite well with over the years, going all the way back with our pneumatic cable cylinders. This type of product is widely used in that industry. So the next one is going to be a better product yet, utilizing the profiled rail. So this is the MXEP with the profiled rail here. That is a THK cage ball profile rail. So when the balls are caged, they actually don't ride on each other. There's a little spacer in between each of the ball bearings, and it provides exceptionally long life and high moment and load carrying capabilities. So again, we've got the 6 sizes available in this product. Thrust capacities back up to 4,300 pounds of force. Load capacity goes up over twice. So we were at 520 pounds before. Now we're at 1,292 pounds. And then you can get up over 2,500 pounds of load carrying capability with a auxiliary carrier. This product has, in the screw-driven design, up to about 60 inches per second and stroke lengths of just right at 10 feet and 3 meters. So some of the features you can see, this is very similar to the BCS. So what we really did is we just turned this extrusion 90 degrees. So the carrier arm and everything still is there. It's just on the side instead of being directly on top. And then we mount the THK cage ball profile rail. Here's a cutaway view showing the little grease pockets that are between each of the ball bearings there as they're retained into the carrier, into the bearing heads. There's 2 underneath each of these carriers. So there's 1 bearing plate here and 1 hidden underneath the extrusion there. So this provides high MX, MY, and MZ moment capacities. It also provides a smooth and repeatable operation and is ideal in clean and dry environments. We've also got this product in the belt-driven version. So here again, now we can utilize the same product as I just showed you, but driven with a belt. So one of the things now is that your motor orientation changes so that it's either underneath, motor down, or you could have the stub shaft and everything coming up off the top here. One of the things that's problematic with that motor being up over the top would be that if your carrier came down to the end of stroke here, your motor and your load could possibly hit. So that's one thing you want to take into consideration when you're speccing in this actuator. So we've got forces up to 418 pounds. The loads at 1,292 pounds. The speed on this one is faster yet, where the solid bearing provided you a speed of up to 100 inches a second. This profiled rail, because of the friction and the bearing design, can actually get you 50% more speed, traveling up to 150 inches per second. And this has then the higher bending moments in all directions on all 6 sizes there. So you can see here Again, my FZ load up to the 1,292 pounds, or on the FY, because of the bearing rail, has up to the same weight there, but the bending moments you can see get quite a bit higher, particularly in the MZ, which is your yaw moment. So if your load was being twisted along that bearing rail, you're going to get quite a bit higher performance than you would with that solid bearing. And so this shows exactly that. So here's your bending moments with the solid bearing, and your bending moments with the profiled rail. So kind of got ahead of myself there. Then we've got the most economic version in the rodless electric actuators is the MXBU. And this unit does not have any bearing technologies incorporated in it. So it is a thrust-only unit. You would need to have external bearing rods or guides holding the load and such. And then this, you'd have your tooling plate to attach to that load, pusher arm or what have you, to just drive this unit back and forth. This one shows a kind of a side view, cutaway view of the two teeth of the curvilinear tooth in the belt there. And so what that does is it, as it's traversing back and forth at very high speeds, you can see that it would not necessarily cog. It holds itself and retains itself, that tooth, into the pulleys on the actuator itself. So we do still have switches, a lot of mounting options here, the tube clamps and mounting plates. And then the motor becomes off the side, left or right hand side, as you would call that out. We've got up to 418 pounds of force. Again, no load carrying capability with this unit, but you do have faster speed at up to 200 inches per second. And this product is kind of neat in that we can splice this, so we can get exceptionally long stroke lengths on this, you know, like 30 to 40 feet in stroke length on this. And again, you've got no moment capacities due to the unguided carrier in the 6 extrusion size.